Hey everybody, welcome in. Today we're going to be taking a look at lesson 12. And in this lesson what we're going to be doing is we're going to be looking at solving multi-step word problems using the standard addition algorithm. And we're going to try and model these with tape diagrams and then assess the reasonableness of the answer using rounding. So we're going to be tying in a couple different skills here in this lesson. I'm going to be looking at addition, solving these word problems, sometimes two-step word problems, and then assessing for reasonableness to make sure that our answers do indeed make sense. So let's go ahead and hop in with number one. Directions read, estimate and then solve each problem. Model the problem with a tape diagram. Explain if your answer is reasonable. So again, assessing for reasonableness. So number one says, for a bake sale, Connie baked 144 cookies. Esther baked 49 more cookies than Connie. And this word here in the directions, more, is super, super, super important. Okay. Esther did not bake 49 cookies. Esther baked 49 more cookies than Connie. So letter A says, about how many cookies did Connie and Esther bake? Estimate by rounding each number to the nearest 10 before adding. So the first thing that I'm going to do is I'm going to sort of draw out and model for us what a tape diagram in this instance would look like. So we'll start with Connie down here and Esther down here. Now, in the directions it says Connie baked 144 cookies. So I'm going to use this rectangle to represent the amount of cookies that Connie baked. So this right here shows 144 cookies. Now, when it says Esther baked 49 more cookies than Connie, that means that Esther baked the amount of cookies that Connie made and some more. So Esther baked those 144 cookies and 49 more. Okay. So what we're going to do is we're going to round these numbers. We're going to follow the directions here and estimate by rounding each number to the nearest 10 before we go ahead and add. So 144, if I were to round, let's say I'm going to round to the nearest 10 in this case. This 4 in the ones is not going to be able to bump up this 4 in the tens place. So this is about 140 cookies. Now, this is the same number would round to the same amount, which would be 140 cookies, and 49 would round up to the number 50. So, question, about how many cookies did Connie and Esther bake? We're going to have to add these numbers up. So we're going to do 140 plus 140 plus 50 then. So I'm going to add these two first. Makes 280, and now I'll make 280 plus the additional 49 that we're rounding up to 50 cookies that Esther made in addition to Connie's 144, which we're rounding to 140. 0 plus 0 is 0. 8 plus 5 is 13, and 2 plus 1 is 3. So I could say together they made about, remember that word about usually indicates that we are rounding. So about 330 cookies. Letter B asks exactly how many cookies did Connie and Esther bake. So we're going to take the rounding aspect out of it, and we want to know down to the precise cookie. So I'm going to use this tape diagram here in letter B. So again, Connie made let's just say this amount shows 144 cookies. And again, Esther made 49 more cookies than Connie, which means she made the same amount that Connie made and some more, and 49 more to be precise. So 144 plus, really, like that's what the second rectangle here is showing, is the additional cookies that she made. So how many did they bake together? So this time I'm going to actually add the numbers without rounding. So same idea, 144 cookies plus 144 cookies. 4 plus 4 is 8. 4 plus 4 is 8 again. And 1 plus 1 is 2 to make 288. And then I'm going to add in those additional 49 cookies that Esther made. 9 plus 8 is 17. Bring down my 7, carry my 1. 1 plus 8 is 9. Plus 4 is 13. 1 up here, and 1 plus 2 is 3. So I could say pretty much the same exact sentence, except I'm going to substitute in 337 rather than 330. So together, they made 337 cookies. And the last one here, letter C, reads, is your answer reasonable? Compare your estimate from A to your answer from B. Write a sentence to explain your reasoning. So what we're looking for in A and B is, our answers here. 337 cookies and 330 cookies. Do we come to roughly the same answer in letter A as we do in letter B? So is 330 close to 337? And the answer here would be yes. Answers are reasonable. In letter A, estimated answer, by rounding each number to the nearest 10 before adding. In letter B, we did not round. The answers are very close to each other. 337 is close to the rounded answer of 330, or something to that extent. Basically, when we are looking at whether or not the answer is reasonable, we are looking at whether or not the rounded answer is close to the actual answer. Number 2 says, raffle tickets were sold for a school fundraiser to parents, teachers, and students. So we have parents getting some, and I'm going to try and color code these as best as I can. Parents, teachers, and students. Jesus. 563 tickets were sold to the teachers. So my teachers being green, I'm going to try and highlight that part in green. Were sold to teachers. 888 more tickets were sold to students than teachers, and 904 tickets were sold to parents. Okay. Letter A says, about how many tickets were sold to parents, teachers, and students? Round each number to the nearest 100 to find your estimate. So we have some information here, but it is a little bit vague. We do have some direct information, and then we have some information that we sort of have to work with. So let's start by labeling parents, teachers, and students down here to keep things as organized as possible. So we'll start with parents. And then we will look at teachers. And down here we have students. And again, using a tape diagram to sort of illustrate this out is probably is a really good strategy to help us visualize, some tricky phrasing here. So 563 tickets were sold to teachers. Okay, so we know how many were sold to teachers. That is 563 raffle tickets. And down here it says 904 tickets were sold to parents. So it's a good practice to try to make these rectangles, the general size. So since 904 is greater than 563, that's why I made this one a little bit longer, this rectangle that represents parents, a little bit longer than the one that does teachers. Now, here's where it gets a little bit tricky because it doesn't tell us how many raffle tickets students got. It says 888 more tickets were sold to students than to teachers. So this is a very similar idea to the last one. 888 more tickets were sold to students than to teachers. So what that means is students bought the same amount as teachers, this 563, and 888 more. So a very common mistake that I would see is that students would think that 888 tickets were sold to students, but that's not the phrasing of the sentence here. 888 more tickets were sold to students than to teachers. So again, students bought the same amount as teachers and 888 more. So letter A says about how many tickets were sold to parents, teachers, and students. Round each number to the nearest 100 to find your estimate. So for parents, we have 904, which would round to 900. Over here, we have 563. So if I were to round that to the nearest 100, 5 is in the hundreds place. This 6 in the tens would bump up this 5 to make 600. And now I need to round both of these numbers. So 563, we already discovered, would round up to 600. And 888, 8 in the hundreds place, 8 in the tens, would tell me to bump up the 8 in the hundreds. So this would be about 900. So all of these numbers we need to add together. So we need to do 900 plus 600, and that will tell us the amount of parents and teacher raffle tickets. So 0, 0, and 9 plus 6 is 15 to make 1,500. And we have really the same two add-ins down here for the amount of raffle tickets the students bought, which was 900 plus 600. Again, adds to 1,500. Now I would add these two numbers together. So 1,500 plus 1,500 would make 0, 0. 5 plus 5 is 10. And 1 plus 1 plus 1 is 3. To make 3,000. So I could say I'm probably going to type this one out because I'm a little bit short on space. So we would say about 3,000 tickets were sold to parents, teachers, and students. Make that text a little bit smaller, move it out of the way a little bit. And there we go. Now, letter B says exactly how many tickets were sold to parents, teachers, and students. So same idea as the last example where rather than estimating, we're going to use the precise numbers this time. So I'm going to copy my tape diagram. So again, the problem told me exactly how many parents bought tickets, which was 904. Told me how many teachers bought tickets, which was 563. And the phrasing for how it explains how many tickets students bought was 888 more than the teachers. So again, the students bought the same amount as the teachers and 888 more. They did not buy 888 tickets alone. They bought 888 more than the teachers. So the teachers' amount and 888 more. So now I need to go through and precisely add these. And I'm going to try and add these all up at one time. So we have 904 plus 563. Again, making sure I'm lining up my place values. Plus 563 and 888. So again, we can add these numbers in any order. I'm going to do it in the order that, just makes the most sense to me. So 4 plus 3 is 7, plus another 3 is 10, plus 8 makes 18. Bring down the 8, carry the 1. 6 plus 6 is 12, plus 8 is 20, plus 1 makes 21, so bring down my 1, carry the 2. Now I see 5 and 5 here, so I know that's 10 right off the bat. Plus 9 is 19, 20, 21, plus this 8 down here would make 29 to make 2,918. So I could say exactly 2,918 tickets were sold to parents, teachers, and students. And last we have letter C, where we're comparing these two answers. Assess the reasonableness for your answer in part B. Use your estimate from part A to explain. So really I'm looking at whether or not 2,918 is reasonable compared to 3,000. So are those numbers fairly close to each other? I would say they are pretty close to each other. You also need to keep in mind, how far you were really rounding when we estimated. So this number here in part A, 563. When we rounded up, we rounded that up to 600. So we left, I'm going to say roughly about 40, or we accounted for about 40 extra tickets that weren't actually sold when we rounded that all the way up. So we did that really twice here also. So we have about 80 unaccounted tickets for that were sort of brought in when we rounded. So we will have a little bit of a bigger gap between 3,000 and 2,918. So yes, answer for letter B is reasonable. The estimated total of 3,000 tickets is close to the actual amount of tickets sold, which was 2,918. 2,918 close to 3,000. Number 3, from 2010 to 2011, the population of Queens increased by 16,075. Brooklyn's population increased by 11,870 more than the population increase of Queens. So that same exact verbiage, more than the population increase of Queens. So again, a lot of times what students will do is they'll see this number and say, oh, that number belongs to Queens. Oh, I see this number, that number belongs to Brooklyn. Let's just add them together. We need to make sure that students understand that this word more sort of accounts for the population increase of Queens and this much more. So letter A says, estimate the total combined population increase from Queens to Brooklyn from 2010 to 2011. Round the add-ins to estimate. So just one more time. From 2010 to 2011, population of Queens increased that much. And try and use a different color. Brooklyn's population increased by 11,870 more than the population increase of Queens. Letter A says estimate the total combined population increase of Queens and Brooklyn from 2010 to 2011. So we have Queens, and Queens's population increased by 16,075. Now Brooklyn's population again increased by this amount, the same amount as Queens, this 16,075 and 11,870 more. So we need to make sure that we account for that extra part there. Okay, so now it asks us to estimate, and let's round to the nearest 1,000 in this case. So we could say Queens' population increased to about 16,000. 16,075 would round to 16,000. That's the same number down here. And I would need to round 11,870. So if I'm rounding to the nearest 1,000, this one is in the thousands place. Peek over at the 8 and the hundreds. That would bump up this 1 to a 2 to make 12,000. So the total combined population increase means I need to take into account Queens and Brooklyn. So I need to add these three numbers together. So I'm going to do it all in one shot again. 16,000, 16,000, and 12,000. Add those together. Bunch of zeros. 6 plus 6 is 12. Plus 2 is 14. Bring down the 4. Carry the 1. 1 plus 1 plus 1 plus 1 is 4 to make 44,000. So we could say, going to need more space than that. So we could say the total combined population increase Queens and Brooklyn was about 44,000. And when we're talking about population, our unit here would be people. So about 44,000 people moved into either Queens or Brooklyn. Now letter B, same idea. Find the actual total combined increase from Queens and Brooklyn from 2010 to 2011. So I'm going to use this tape diagram again. Same tape diagram, 16,075 people. Now Brooklyn's is not just the 11,870 people. It's that much more than Brooklyn's. So they have the 16,075 people move in plus 11,870 more. So again, need to add these three numbers together. 16,075 plus 16,075 plus 11,870. Again, lining up my place values to make sure I'm adding ones to ones, tens to tens, hundreds to hundreds. 5 plus 5 plus 0 is 10. 7, 14, 21, plus another one is 22. 2 plus 8 is 10. 6 plus 6 is 12, plus 1 is 13, plus another one is 14. And 1 plus 1 plus 1 plus 1 is 4 to make 44,020. So again, I could say exactly 44,020 people moved into Queens and Brooklyn in 2010 and 2011. Letter C asks us to assess the reasonableness. So we're looking at whether or not 44,020 is close to our estimated amount of 44,000, and those numbers are very close to each other. They are only 20 off. Therefore, we would say that, yes, the answer is certainly reasonable. So my answer is reasonable because the estimated amount of 44,000 is very close to the actual amount of 44,000.